Okay, so the topic is creating WSGI middleware. I think some people just say WSGI. I like WSGI, so bear with me.
The one I've heard lately is wise guy.
Wise guy sounds.
I
I've
like
heard.
that.
I've heard whiskey. Whatever your thing is, creating WSGI middleware. So basically, my hope is with this talk, it goes in a little bit of depth, but I'm hoping if you're new to Python that it'll at least kind of show. You'll see how some of the pieces fit together when you build a larger application. So I actually prepared a little bit of a project beforehand to show kind of a contrived problem that needs to be solved, and you can at least maybe learn a little bit about how you can lay out a Python application, stuff like that. What is and isn't WSGI? WSGI stands for Web Server Gateway Interface, and it's really nothing. WSGI is not a thing. It's not a library. It's not a tool. It's not a framework. It's not a program that you run. WSGI is basically just a set of rules. Python's defined it. They have these PEP documents that basically say, here's a set of rules that we want to follow in the Python community. And the set of rules that they made for Python web servers is called WSGI. And it's basically, here are a whole bunch of rules for how a web server should talk to a web application. And here's how the web application should talk back to a web server. So basically, you say www.minted.com, and your request hits a web server. And then that web server needs to somehow be talking to the Python code. And if all the servers did it a different way, it would be really hard to build frameworks and applications that could talk back to the server. So we want a really standard way that our applications can talk to a web server that needs to serve Python. And so WSGI is the way that happens. It's basically, there are two parts to it. There's what a server can say and what they should say whenever they talk to an application and what they expect to get back. And then there's the other side of it, which is what an application expects to receive and then what they should say back. So some examples of servers aptly named UWSGI, GetUnicorn, Waitress, Apache, if you're more familiar with that one, kind of was the king of servers for a while, has a module that supports kind of that WSGI dialect. So those are the things that are running and receiving requests. So whenever somebody goes to minted.com, it hits that URL, server's the first thing they're hitting. And then some examples of frameworks. Django is the most popular probably in the Python world, Flask, Pyramid, Web.py. And all of these frameworks, because Python has said this is the way that we're supposed to talk to servers, all these frameworks basically follow that pattern. This is how they're, and somewhere in that code, whenever your server says, I want to talk to Django, it's talking to this central part of Django using WSGI. It's talking in the same way that it would talk to a Flask application or to a Pyramid application. So you could swap out, you could run any Pyramid application or web framework on any any Python web application or framework on any Python serving server. Does that make sense? So it's just a way that things can be a little bit more compatible and the tooling can be more portable. So who has Git installed? I don't know if anybody has Git installed on their machine. So if you do, you can clone the chips in on an example or some links to these slides. So if you actually go to this slide, it's going to be on that slide is a little GitHub demo that I put together. Clone it down to your machine and check out the start tag there. So we are in the state where we do that. So this is actually an example of a small web application. This is an entire web app as far as it can receive a request and it can send back a response. And this one is really, really, really simple in that all it does is sends back a response that says, yep, success. And then it gives us an HTTP status. So within the web, there's always a number that represents the status of a request that your browser makes. So the browser can say 200, which means, okay, they went well. We send some headers back saying this response is going to be JSON. JSON is just kind of the standard data format that applications use to communicate. tells us how long that response is going to be, and then sends it back to the server. So looking at this, just to kind of point out which parts are WSGI, every single Python application that speaks WSGI, or Python framework if you use Django or something, is going to have this method that gets called by the web server. And the web server is going to pass in an environment. It's a dictionary that has a whole bunch of things about the request that's coming in. And then it's going to pass in this start response, which is essentially just a method that the application calls whenever it's ready to send stuff back to the server. So every single time a request goes in from a server to a Python application, it's looking for this method, and it's saying, I'm going to pass in an environment variable, and I'm going to pass in the start response method, and I want you to call that method whenever you're done and you're ready to send stuff back to the server. So this small example, I guess I can go ahead and start it up here. So we will say, and actually I have a server too. That's what I was just getting ready to run, but I'll show you the server. So Python actually has, in its standard library, it has a little WSGI server built in for you. You probably don't actually want to use this out in whatever.com you run, but it's a really good little, if you just want to stand up a quick Python application on your own machine, there's this WSGI ref package inside the Python standard library, and it's got a simple server in there that speaks WSGI. And so I can say I want to import my application here. So kind of zooming back out, if we look, I have this module. Sorry, I have my API endpoint package here, which includes that Python application. That's really small. Which includes that Python application. And so over here I'm saying I want to import this simple server, and then I want to import my application, and then I want to marry those two together with this one file. So this is really just a little script. We're going to print out serving it on port 8000, and then we get this handy make server method that Python standard library server gave us, and we tell it that we want to pass in our application. So this is, and then we say serve it forever. So it's basically, it's not going to stop. It's not going to quit once it gets one request. It's going to keep going and listen for more and more requests. So this is all that's needed really to wire up an actual web application. You just saw in, I don't know, how many do we have here? 8 plus 26, so 34 lines of code for a fully functioning web application. So written in Python. Python serve API, so there's our printing out serving API on port 8000. And now if I go to my browser and I say localhost 8000, then I get my success true coming back from my WSGI application. So there's the server that handled that request to localhost 8000, and then that that server knows how to speak WSGI, so it looked for this application method, and we told it what that was when we did that little make server thing. We said, well, the application is going to be my API endpoint that I imported right here. And then I want to serve it. So the server calls that application method, sends it the environment, sends it the start response method to call, and then the application calls that start response method with the content that it wants to send back, and it makes it back to our browser through the server. So let's see where we get. I made another little WSGI application in here. I call it client button. And all it does is it opens a file that has some HTML in it, and then it reads that file. It says, okay, that was a good response. We're going to send back HTML, and then it sends it back. So this is like how most websites you're used to working with function. The server says, I want to open an HTML file, and then I want to spit it back out in the browser once the response goes back. So this one, the HTML file, just to show you what that looks like. The HTML file just has an AJAX, a big button that says send an AJAX request. So we're going to make a web page that calls that other server that we just, or application that we just wrote. So we have this application here that just says success true. And now we're writing another application over here that's supposed to call over to this one and get a response back. So that happens whenever you click that button, and that's what this code does. We're either going to get a success or we're going to get a failure. Still following decently? Okay. So if we start this one up, I made a similar little script that starts, instead of starting just one server, so I've got this simple server here again. I import my client button application, and then I say I want to run it, but instead of running just one, I run 3. So I'm going to run one on port 9000, port 9001, port 9002. I'll show you why. So let's start that one up. So now right here, it started up 3 more web applications for us. One on port 9000, one on port 9001, port 9002, and all they do is respond with the same HTML. So they're going to render the same HTML back in the browser. So I can say localhost 9000. There's my big send AJAX request button. Localhost 9001, same application, localhost 9002. Okay, so this button, as mentioned, it's supposed to send a request from JavaScript back to this localhost 8000, this other application that we wrote that just says success true. And then it should say the request succeeded or the request failed. So I hit this, and request failed. So really all I'm doing actually is setting up a problem that we can solve with WSGI Middleware. So if it's any questions that might clear up anything at this point? Why is it failing? That's the question I'm just getting ready to answer. Yep. So our browser gives us a hint down here. And this is a really, really common problem. So a big pattern. Yeah, it will bite you. If you ever build web applications, it will bite you at some point. It's getting really, really popular nowadays. If you think of like a logged in Facebook.com experience, you're actually getting this massive amount of JavaScript, and your browser is basically holding the whole application, and then it's just calling back to various endpoints in the background to retrieve, what your friends are doing and what your mom's doing, and it's getting really popular to build these applications where everything happens just on the page in JavaScript, and they call back to these endpoints. And so companies are starting to break apart their applications into multiple services, like small other applications that just return the data that you need instead of returning any HTML at all. Kind of like we return the success true. But if you host that somewhere else, then JavaScript, whenever you try to run it in the browser, says, I'm sorry, you can't, you're serving this application on localhost 9000, but you're trying to access something that's on localhost 8000, and we can't allow that. Because what if your bank account is localhost 8000 and my bank reading homepage.com is localhost 9000? You don't want my bank reading homepage.com to be able to read the data from your bank account. So the browser says, we aren't going to let that happen. If you want that to happen, this application, this success true application, localhost 8000, if you want that to be able to happen, it has to be able to respond with a special header that tells us that it's okay for localhost 9000 to talk to it. And I'm going to open a little tool I like. If you've never seen Postman, if you're a Chrome user, it's a nice extension. You can just send a request. You can set it up. Postman? Yep. So you can just set up a request however you want. You can add some headers, which is nice. Kind of pretend to be a browser and send the request. So I'm going to send a request to localhost 8000. So it's just like when my browser sent a request, I got success true back. But we want to look at the headers. And if you look here, what my browser wanted was this access control header coming back that was going to say it's okay for localhost 9000 to call this resource. And we don't have that, so Chrome just says, heck no. So same thing is going to happen on 9001. Request failed. So I just copied this application 3 times so that you could see, like, no matter what other domain. And picture, I'm doing it on local ports and stuff, but picture that these are just different domains. So it's a cross-domain issue is basically what we're running into. So that's cross-origin resource sharing, and nowadays that header approach is kind of the de facto way to say it's okay for this other resource to talk from JavaScript back to my service. It's just, you know, getting good enough support that you should be able to use it in your modern browsers. If you have to support really old browsers, there are some really dirty hacks that let you handle that. The are you talking about the
request authorization? So that's a server.
yeah, so what, right, that's saying that you can't have access. So the server, the browser is the one that's saying it's not allowed because
Yeah,
the
I know that.
but
Who codes that to say, yeah, this is allowed for that particular domain?
right. So the question is who codes that to say that it's allowed from the particular domain? And the answer is the service that you're trying to call is the one that needs to explicitly say who's allowed to call it. So this localhost 8000 application has got to say I'm going to allow localhost 9000, 9001, and 9002 to make calls to me. So to do that, we could just go into our application and yeah, because it's happening in that call is happening in JavaScript, so it's the code's already down in your browser, and it's on. So imagine that. Yeah, the browser is going to say if I don't see this resource specifically telling me that it's okay to allow these people, then the browser itself, it's actually a feature of the browser. So there's no reason, and in fact, actually.
So it does go check with the server, and the server just doesn't return anything to the browser.
Exactly. Yep. So it goes and calls the server, and then the server set. And actually, if you want to get really nerdy about it,
The server will respond.
Yeah, it responds to something.
we can and we can look at these requests. So this is the request that went up from the browser, and you can see that it called localhost 8000 with a GET request. I want to get some info from it. And the response returned these headers. But also, it's kind of interesting, the response that actually hit that part of the server, but the browser is just saying, I'm not going to let you have access to the data. Like the browser can have access. You can anybody can just go to something in their browser, but it's saying when you're on this page, I don't know what this page is going to do with that data after it comes back from some other domain, from some other web page. So this is the reason that, you know, some advertising network can't read your browser history and see all the websites you've been visiting, or you know, or who all your Facebook friends are, without some kind of.
We just set the cross domain on our server to say allow all, and it doesn't. I mean, it has literally no impact on the text.
Well, so the problem is, you know, you could say, and actually that's where I'm going to go with this next, is we could say. So going back to our original WSGI application, that one that says success true, we could say, I just want to add one more header here. And just say everybody. Cool. So now I restart my app. Whoops. And now, I am such a grateful developer because all of my code works now, and my JavaScript can call my backend. The problem is when you have sensitive data from your customers, now any application from JavaScript, if it wants to, can call back to that service because you allowed all. So you've just opened up your endpoint.
So that's why mixed content is a problem, right?
Like secure content and insecure content.
Yeah, you get browser where it's like images or assets
Right.
like they
Yeah, I've
are
seen
not
that.
SSL.
So that's like if you visit a secure site like your bank, and then your bank embeds something inside the page that's not secure, then all the data that you transmitted back and forth to your bank was encrypted, but then there's going to be this one little pocket where it's like, hey, we can't allow that in there because, so your browser, they're getting better. Browsers used to have really janky security features. Our browsers are getting better at protecting us.
So the code doesn't stop at your phone. That's where the cross-site scripting comes in. Cross-site scripting is
Well,
the actual call from some script to go out to some of the node.
well, an XSS attack is usually when somebody, it's usually a flaw in your application. It doesn't sanitize the data that somebody submits. And so that you allow, like, if you could post JavaScript on Facebook, for example. So, yeah.
It's validating the input of a form improperly. If you don't
Yeah.
remove script from it, so you're able to just submit script. Here's the script from my server. That's a bad script.
So
It's
the
gonna affect
process
the page.
it's bigger than that. So it's like if you want to take and have some third party load a, let's say you're running a 300 by 250 ad. It's going to HTML ad. It's going to potentially be calling resources from a third party at the site. It wants to, but it can't because the originating site wasn't the site that was where the original code was served. So that's where cross-site scripting for this the third-party data collection.
Yeah, I mean, it's just simply you're embedding a script tag on the website.
Yeah, it's the equivalent of, like, if I could post on Facebook a chunk of JavaScript code that told me that sent me personally all your messages, all the messages of everybody who happened to load that page over to some. So yeah, cross-site scripting is another serious secure. So the thing is, you can button up one security problem like a general, if you allow access control like this with a wildcard, that's one big security vulnerability. But if you have a cross-site scripting vulnerability, you haven't buttoned up your application entirely. So when you're working on the web, it's very important, as our governments have shown us, to make sure that you are handling security carefully of people's data. So the problem now is, what if? Well, first I want to, instead of editing that in the application, I want to show what it could look like if we did it with a WSGI middleware, because that's what this talk is about. So we're learning all kinds of things. So middleware, basically, this is just a wrapper. So we're just going to say we had that application method, right? That returns our application, and we're going to wrap it with something else. So I debated whether to live code all this stuff, but instead I've already coded it. So I'm just going to check out that code, and we'll see what changed. Actually, I think I skipped step. Oh, there was no step one. Start was step one. Okay. So now if I go back to my application, well, nothing is going to change on the application here, but I added a new file. And this commit will kind of show that a little better. I added a new file here called cores middleware. And it's just a method. And all that method does is takes the original application, and right now it just it says we applied the middleware, and then it returns the original application. So we didn't actually change anything, but I'll go ahead and show what that looks like. So here's my cores middleware. And whenever my little server boots it up, now I say my wrapped application is my original application passed into this cores middleware. And so the cores middleware says, I'm just going to return the original application. And then instead of using the normal application that we passed into our server, we're just going to say call wrapped application. Does that kind of make sense? What's happening there? This is actually, if you're familiar with decorators, this is kind of the same idea. You're just wrapping up a method with something else. So now whenever the server gets a request, it's going to call wrapped application. All wrapped application is the original application because that's all we did with this middleware. But we're going to print this out whenever we start it up. So if I go back to my server, you'll see that whenever I start it, it says cores middleware applied because we said to print that out. And then we'll just return back the original application, and it'll do exactly the same thing. So if success true, nothing different. The headers aren't going to be any different in our request. So let's see here. See what exactly is happening here. Okay, so now we're going to get a little more creative because instead of just returning the original application, we want to return a wrapped application that does something else before it even goes down to the original application. So this is basically WSGI, right? It's servers talking to applications. And we want to make something that can sit in that process and just do whatever it wants with it. So kind of intercept whatever's happening in that communication between those two. And so for step 3, so one example is, and this is what I'm trying to show basically here how we could inject a header, for example. So every request that goes to the application, I want to inject an access control allow origin header so the browser knows that it can make that request safely, right? But what if I didn't write the original application? What if this was Django? Then how would I get into those internals of that request? Or what if this was Flask or Bottle or web.py and I wanted to get into that process and always inject a header in there on no matter what you were calling in the application. I always wanted to inject a header. Well, then a middleware is nice. And you know what's cool about WSGI middleware is if you make it speak WSGI, then you can wrap it around a Django application, you can wrap it around a Pyramid application, a Bottle application, a Flask application, a web.py, web2py, all these different frameworks.
Or so if you're getting someone else's application.
Yeah, or
someone else in a different part.
Exactly, yeah. Or different teams working within an organization is what Caleb was saying. Like, yeah. So maybe you want to say to everybody else in my company who's dealing with these cross origin issues that they can't make these calls, just drop in this WSGI middleware on your application, and from now on you'll have that header and you don't have to worry about it. You don't have to think about it anymore. So that's what we're trying to get to here. So basically this next step, we had a CORS middleware that just originally returned to the original app, and then we make a change and we say now instead of returning the original app, I want to return a new wrapped application. And this one is eventually just going to call the original app too. So we're going to do some stuff in here to like kind of monkey with what the application does, and then we'll just do whatever the original application was supposed to do. And then we say instead of returning that, we return this wrapped application. So we're getting like layers upon layers here of just wrappers around wrappers. Sorry. So now we're going to wrap again. This is where you don't understand, maybe. You know the call stack it's most likely you're going to have operations within your application that are bigger bottlenecks than these calls, these function calls happening. So theoretically, it could be you're not going to deal with that until you're at a very, very large scale of company. So it's a really good problem to have if this call stack is adding too much latency to your application. You have a lot of users at that point. So we have this application, right, that's modified that we want to return now. So every application, you could pass any application to this middleware now. And no matter what application you pass to it, it's going to wrap that application with a little bit of functionality, and then it's going to send back whatever the original application did. But now we're going to get inside there, and we're going to monkey with this start response method. So we don't know what the application is going to pass back, but we know that imagine that it wasn't my success true application. Imagine that it was facebook.com, and we just wanted to inject some header on there. Well, whenever facebook.com WSGI application calls start response, it starts sending a response back to the browser. We say, I want to get in the way of that, and I want to do my own thing to that response before it goes back to the server. And so I'm saying, I want to actually add this access control, allow origin header, and then I want to send back that response as it originally was. I want to return the original app, and then I want to return my modified application. So we've got wrappers within wrappers and within wrappers, and we're basically just saying, always send back this header. So now, if I start my application, CORS middleware was applied. Send a request, and you'll see it added this access control allow origin header. So that's awesome, because that means now that our request can go through. But it's also not awesome because we just made our application open to any JavaScript application. We just introduced a big security problem. So what if I only wanted to allow localhost 9000 and 9001 to make a request to my application, but 9002 is the bad guy, and he wants to steal my bank info, and I don't want him to have access. Then I've got a huge problem, because now he gets the same little celebration everybody else does. So I could, okay, maybe I can just modify this access control allow origin header so that I say, now I want to allow localhost 9000 and localhost 9001. Let's restart our server.
It's fine. It's the same thing as putting in the original code.
It is, except when I put it in the original code, it's not portable, right? Because I can't wrap any application. I have to modify the application itself, the original application. What I'm trying to do is to be able to say, like Caleb was suggesting, to another developer somewhere else in my organization, I don't know what kind of WSGI app you wrote. I don't know if you're using Django or Bottle or Flask or Pyramid, but put this in wrap your application with this middleware and you'll be good to go on CORS issues. And that's something, otherwise I would have to send out an email to everybody else in the organization and say, hey, everybody update your application so that every endpoint in your application is returning this header, and tell them how to do it. They don't have to think about it. They can just pip install my middleware and then go ahead and wrap their application in it. So we just restarted it. So I say, cool, now 9000 and 9001 should be allowed, and they're not. And the problem is we're learning as much about CORS as we are about WSGI. Access control allow origin header contains multiple values, 9000 and 9001, but only one is allowed. So unfortunately, our spec for CORS says you can actually only send back one. So you can either say I want 9000 allowed and nobody else, or you can say I want everybody allowed. So what if you have multiple multiple applications that all need to be able to access your service? This is where we make it dynamic. So what we're going to try to do is say, whenever a request comes in from localhost 9000, I want to return a header that says allow localhost 9000. Whenever a header comes in, or a request comes in for 9001, I want to say allow 9001. Whenever a request comes in for 9002, don't return any allow access control header. I don't want them. Let's see. So, get this out of the way, zoom in a little bit. Okay, so here's our wrapped response that injects this, right? I'm going to make some modifications here. Bam! Okay, so here's our new middleware. Fastest coding you guys have ever seen. So now my middleware takes the original application, and then I have a whitelist here that says allow localhost 9000, localhost 9001. Whenever the request comes in from the environment of the request that the server gave me, I know that there's this variable because the WSGI spec says there's a variable called HTTP origin that tells you where that request is coming from. And actually, you can even see this whenever this request goes through. We can see it in the browser, that the browser identifies this request originated from localhost 9000. So that's the origin header that we're getting from the original request. So the request comes through and we grab the origin, get a hold of it. Then we do our typical thing where we inject the header, but injecting the header, we inject the origin. And then we have this handy little validate origin method up here, which just says, yeah, if there is if the origin was specified in the request and it's in our whitelist, it's valid. So we say validate the origin, make sure it's in our whitelist, and then if it is, return the response above, that wrapped response. So we've got this CORS allowed response, right? And it's a wrap around the response from the original application that just adds a header, and that's all it does, and then sends back the original response. Well, now we're going to say if it's a valid origin, then I want you to return the original application but with the wrapped response that allows that origin. And if it's not from somebody on our whitelist, then I just want you to return what the app would have originally responded with and don't add anything to it. So now, if we go and we start this,
So where does this middleware live?
S-
Around the application?
yeah.
It's installed on the server.
Right. So typically it's the middleware is gonna, like, did you see our? Let me actually pull up that example again. So this is where our API gets served, and we imported our middleware here, and then we wrapped our application in it, and then we passed our wrapped application to the server. So usually there's some little script that starts the original process of booting up your application with the server, and it ties those two together. And so we're just going to import it and wrap it around the application right there. And when you use a framework like Django or something like that, actually Django has their own middleware stuff that's totally a better way to do things. But if you're using like Flask or Bottle, then wherever you actually start the application with the server, that's usually where you would just wrap it with the middleware. And some frameworks have really clean ways of doing that, and some you just list out the middleware that you want to apply, and then it's applied. But we're doing it really explicitly here. So now I'm going to start that server. This server should respond with the origin. Woo! Anybody want to print out of my TMUX session? Okay, so now send AJAX request with origin 9000 success. And if you look at the response that we got from the server now, you'll see we got this allow access control, allow origin 9000. If I go to localhost 9001 and I make the same request, success, and I go down here, and now instead of access allow control allow origin localhost 9000, it says 9001 because that was the origin of the request. We explicitly allow that one. Now I go to 9002 and I send the request. 9002 wasn't allowed to access that. And you look at the response headers and there's no access control header at all. It just returned the original response that was failing when we first started. So a small thing here, but I don't like that that whitelist is hard coded into our middleware. So we've got the whitelist right here now. Instead, I'm going to make it something that you can pass in whenever you wrap that middleware. So we'll just say put the whitelist up here as a parameter to the middleware. We can just pass in a whitelist, and then if the whitelist is none, just set it to an empty list. And then if I go back to where I serve the application now, I can say wrap my original application with the core's middleware, and also pass in this whitelist that allows localhost 9000 and 9001. So my code just got 1,000 times more useful, because if I want to send it to somebody else in my organization, now I can say, not only can you put this in front of whatever kind of WSGI application you have, but also you can send it any whitelist you want. So that whatever things you need that are supposed to call it, you can allow them, and we're not going to have to all share one big master whitelist across our organization and have some way of passing that around or calling it. So it made our app a little bit more flexible. How am I on time? Is that okay?
I have plenty of time.
Cool. It's not much longer. But
As long as you want to be here.
10
We're
steps.
here
Okay,
as long as
cool.
you want.
I don't want to. Am I losing? Is it still? We're still tracking.
No, it's
Okay, cool. Be classy. So some people like classes. May or may not be Pythonic. But let's go ahead and, just for the sake of testability, readability a little bit, we're going to turn our middleware into a class. I'll just kind of walk through it. Oh, I need to change steps here. Step, or do I? Yes. Did that say step 7? Yes. So, bam. Now I have this cores middleware class. So I'll show how we instantiate it again too. So now, really the only difference here is I capitalize some letters when we import it. And what's that? Any state within the class itself? Right. The only thing would be the original app itself in the whitelist, right? Is pretty much, and no, that state doesn't change. But you can do that. You can not do it. I just kind of want to show the idea of defining a middleware as class can have some benefits. So in this instance, if you're new to Python, capitalizing letters is not changing anything. It's just normal to capitalize classes like that and use underscores and lowercase letters with methods. So basically, whenever we pass in the app, when it's first called, this is in Python, we initialize that class, create an instance of it, we pass in the app and the whitelist, empty whitelist if there wasn't one, and then we just hang on to those for using them later. And then down below, we have this call method, which is essentially that when you call this like you would call an application, this was our original method that we were returning as our application from our first wrapper that takes environ and start response, gets the origin from the request. If it's a valid origin, it returns the core's response. If it's not a valid origin, it returns the original response. Here's our core's response factory. This is what you get if you switch classes. We'll start looking like Java, which creates the response with the dynamic origin over here and returns that response callback. So that really didn't change anything objectively with our application. It's just another way to write middleware. As long as it's callable, it can be a middleware. Okay. This is just maybe, I guess, a little bit more exploration into cores and can take us a little bit deeper into WSGI. Sending data is another security issue. So I modified my client application to add another button that says post some JSON. So this is a request that's supposed to change something on the server. When you click that button, that happens. It tells us successor response, or sorry, successor fail, just like the original button. So now if I go back to my cores button applications, those three, you get this post some JSON thing. And that method is, all it's going to send is this little payload. I'll go ahead and zoom in on that. So basically, whenever you click that post button, it's going to send a post to that backend. And it's going to, right here, it's going to identify that the content that I'm sending is JSON. And then it's going to send the actual JSON in there. So this JSON just says update thing. So the server knows when it gets this, it should update the thing. So now my AJAX request, my original one, oh, that's on 9002, not allowed. If I send it, good, success. If I do post some JSON, 9000 is not allowed to do that. And we go down to our console here, and we can see that now we're missing another header, access control allow headers. We can't send a content type JSON to this server. So let's see if I changed already in this step. I don't know if I did or not. Nope. Okay, so let's check out another step. So the interesting thing is when you look at the server, the request that was issued, whenever I made this post request and it failed, what the browser actually sent, so these were my GET requests when I pushed that send AJAX request button. They look normal. We're just saying get something from the server. So you would expect that when I said post a request to the backend, it would send a post request. It didn't. It actually sent this options request. And this is basically the server's way of saying, or sorry, the browser's way of saying, whenever you make a post request, it's implying that you're changing something on the server. And we don't even want that request to be able to hit the server at all until we're sure that we have access to it. I don't want you changing something in somebody, transfer funds from X account to Y account without knowing that it's okay for that request to even hit the server at all, like the application at all. And so it sends what's called a pre-flight request. And that's what this options request is. And so it's actually going to send 2 requests every time it tries to post data when it's got JSON in it, because the browser wants to know, first, options. What options do I have here? Can I access this? And then if it says no, then it's not going to send another one. If it says yes, access control allowed, then the browser will follow up with a post request. So we're going to fly a post request, and the options request is called the pre-flight request. and our applications are currently on the no-fly list. So so we're going to modify our middleware a little bit to allow this pre-flight request to be handled. And so all I did was I added another small application inside of my middleware. This is a full WSGI application. So this time it's not even just wrapping some other application and returning its response. I made a full application that this is what one application that the request could hit. And it basically says okay. It's the text. And then it returns the origin, like we did in our other response. But it also sends this thing saying, yeah, it's okay if you send me JSON data. So this request adds that extra header that Chrome was looking for before it was gonna. So the options request came through and said, hey, is it cool if I post to this endpoint? And then the server didn't say it's okay to send this content type. And so the browser said, okay, never mind, I'm not posting. So what we're trying to do is have something that responds to that options request in our middleware. And so I made this little application, and whenever we receive an options request, hold on just 1 second. Okay, sorry. Whenever we receive an options request, so here's another variable from our environment. What method was the request that came through to our application? If that method was options, I don't even want to return the original application at all. I just want to return this application where all it does is say okay and give a handful of headers. Sorry. So now, if I restart this server with my new middleware, I go back, 9,000, post some JSON, we have success. And if you look at it, down here are, so here are 2 requests that went through. If you actually, let me clear my console and I'll do it again, just so you can see that there's just 2. So first, that pre-flight request went through. It said hit the endpoint. I want to check and see if it's even okay if I post JSON data to that endpoint. And the reply from our server was the reply from that small little WSGI application we made inside of our middleware that says, yes, you can have that content type header in your request, and also I'll allow your request to come from localhost 9000. And then it just said okay. That was all it gave us back. You could probably even respond with an empty page, an empty body. And so then the browser knows, all right, I saw that header, we're cool. All on the same page here, let's send the post request, which got the original success true response. And then just kind of to show how this is just exploratory. So it's the last step, step 10. I added one more middleware here. Remember what it was called. So timing middleware module here. And I have a response timing middleware that wraps your application. And then this one's incredibly simple compared to the other one. It just, whenever a call first comes into the application, it saves that time. Then it gets the response from the original application. Then it sees how long that application took to respond. And then it prints out the response time. So we're basically, this middleware, all it does is tell us how long it took us, our application, to respond to that original request, and it should print it out. But if you look at where I serve my application, so now we're wrapping things like crazy. So now I have my original Cores middleware that wraps my original application right here. And around all of that, I've added my response timing middleware. So you can see that you can stack WSGI middleware on top of each other, and you're just wrapping applications and applications and applications, and you're just doing things with it along the way. And so the first application, the Cores middleware application, actually monkeyed with the response and added some headers. And the timing middleware doesn't do anything to it. It just measures how long from the time that the request came in to the time that the response went back out did it take, and I'm going to print that out so that you can debug if you have some slow endpoints. And so now if we run this application, and we make some requests to it. Send an AJAX request, post some JSON, post some more JSON. I can go back to my logs here, and I see that my middleware has spit out this GET request. It's a very fast application. When you don't have any disk I/O, database calls, no API requests. If you ever make an application this fast in production, please call me. We will hire you. Unless it just does this, in which case I don't know that's a business goal of ours at this point. So this is really, really fast, and this, yeah. So anyway, those are milliseconds. That's really small. So this application is super fast. So you also saw how to write a really fast application. And actually, if you really whittle it down, writing just a pure WSGI application, if you don't need to do anything complex, it's not a bad idea. It can be a pretty fast, nimble thing without a huge call stack or framework or libraries to, bring around when you're deploying it. So,
So what are some real world examples of
yeah, examples.
Well, yeah. I mean, I was going to make some joke about like Java Spring Framework, but really it's very similar. And you can explain WSGI like in a way I never understood why I needed it. But like the Spring Framework, I mean, you can apply logging or exception handling. You can apply authentication and access control. Those can be managed by other teams, right? So the people writing core logic of your app don't have to worry, but as long as you wrap everything with access control middleware, then that's built in.
authentication?
Yeah, it's also the idea of like aspect-oriented programming, right? Like your aspects span across your functional activities. No, I think this is like explains some stuff I've never really done about this.
Sweet, super sweet. Josh, do you have any good examples of like WSGI middleware that are like kind of useful?
The example that you showed today is pretty agile one.
We're using that in production at Minted.
We're using that in production today, and also timing middleware. If you ever use Django, for example, you use debug toolbar, suggesting that uses WSGI middleware. You can also go to the model tool. Most popular web frameworks have variants of that. A good way of thinking about it is if you're slicing it down into the brain, there are multiple layers. Anything that you can think you might want to wrap around that central core of your application where it doesn't care about what's going on necessarily in the middle layer, you have out exterior concerns. It's applied to many different cases. The timing application, the cores, those are both really common today. If you were to jump on like Django packages and search for WSGI middleware, you probably hit anywhere from 40 to 60 packages, I guess. I mean, there's going to be quite a few. I think that's it's far-ranging, and I think certainly it's a good approach if you have something that you need to sit on top of or on the egress of your applications.
Is Apache Storm, is that an ORM? Okay, there's a Storm ORM. I was looking for some good examples of, middleware that's out there that's kind of useful. JSON Pretty Printer WSGI middleware, that's kind of interesting. So imagine if your web server returns JSON responses, but a lot of times they'll be all compact and unreadable. So this middleware, you can just throw it around your application, and now all your responses that come back will be easy to read. Image transformations, let's see, recording your requests and responses. So maybe you wanted to log like everything that came in and everything that came out. You wanted to save it so you could look back at it later.
At LJ, at the Fortune World, we had a WSGI middleware that would create thumbnails on the fly. So a request would come in and it'd say, give me a thumbnail that has this dimensions for this thickness. And that WSGI middleware would say, oh, we don't have that thumbnail. Let's create one, and then we'll return the response. Now, this is the WSGI
Yep.
layers upon layers there. But yeah, anything we can think of, it's worth always trying to isolate concerns, right? Keep the concern separate. So there's a valid approach for a lot of different problems.
So yeah, it's kind of a nifty thing because you could make a middleware library that, if it was useful to you, it probably is useful to somebody else. Throw it up on PyPy and pass it around because they fit in between all kinds of different servers and applications and do a lot of cool stuff.
Question, I don't work with this kind of stuff. The question I had
Yeah.
is why would the server return the data without the header if you weren't allowed to see it? Instead
So,
of sending you back
yep.
a response that says, go the hell away, you're not allowed to see it.
In that instance, it's actually, if you're just doing a GET request and you're not changing anything on the server, it's actually fine if your browser sees the response, right? It's just not fine for that web page to access it with JavaScript. Do you get what I'm saying?
Well, I understand. Then I have to trust the stuff. Have to trust the browser to hide.
You have to trust the browser. Yes, absolutely. Do not use a web browser you do not trust.
And so I mean, it seems odd that the server wouldn't
Very
just deny and not send any data back.
Yeah,
say,
totally.
Go away. Instead of, I trust you. Here it is.
Yeah.
Don't show it.
Yeah, exactly. Yeah, because the browser, and I could just open another tab and always go to localhost 8000 and make a GET request, and it really doesn't. The server doesn't care where it's coming from, but the browser cares that one website's JavaScript can't access some other server's data directly.
But the service has to have some kind of authentication. It can't just trust anybody that knows where it is.
It's not like greater security model.
Right. The HTTP was created with zero security.
The thing is, a lot of times so imagine, and that's actually true. So if you have good authentication in place, you can access control wildcard. The problem where that falls down is a lot of web applications use cookies for maintaining your login state. And so now suddenly every request that I send to localhost 8000 is logged in. So it's authenticated. And if that's the case, then whether that request comes off of another page or not, it doesn't matter if that. Right, and it's making a request to that domain. So if that request is allowed to go through authenticated, then you're getting, even though there's authentication in place, if the authentication is based on something that's passed with the request, which a cookie is passed up with the request to that domain, if your JavaScript allows it, and if with credential, like there are other constraints, make sure you want to do that.
It's all,
But
it's kind of a separate discussion, but it's a whole ecosystem. Like, if you use an insecure password, no security is going to help. Like, there's a lot of components of security, of which this is only one.
yeah, I think the browser security features tend to be the ones that are the most frustrating for developers, because it's like, why can't I just make that request? Like, prove to me that that's a problem, especially if you have an open API, that it doesn't matter if something else accesses it from anywhere. And then you have to deal with this header stuff. But yeah, we really have to, the servers are responsible for deciding whether or not they trust the clients, but the browser has a responsibility of making sure that the JavaScript and the applications that are running in different tabs and in different processes from different domains are not interacting with each other in a way that's not.
JavaScript in the Netscape browser when it first came out, JavaScript was being used. Was there security then, or was it already?
I don't know. I actually don't even know if you could make these asynchronous calls back to servers.
Until the asynchronous stuff was introduced by Microsoft, actually. And
Yeah.
IE3.
In the IE browser, yeah.
Right, was it IE3? Does that sound right? Yeah.
And it probably wasn't very secure when it first came out.
Security feature that's marking browser today was assuredly a problem at some time.
Right.
I can guarantee you that.
Well, and when I say HTTP was designed with zero security, Tim Berners-Lee was wanting to put up scientific papers for anybody who was on the internet, which was mainly academics, to be able to access because it was free. There was no idea that somebody would be, even basic auth was not added on HTTP.
They weren't
1.
applications
It was HTTP
even.
1.1. It's
Yeah.
right. But
And
being different.
this is-
server is HTTP.
This is why it's like people were rightfully scared to pass their credit card information over the internet when applications started asking for it. And like some applications probably still take credit card information without an encrypted connection,
That's a big problem now where it's pretty common for PC things. There's people that use PC
Yeah.
cafe.
So that-
They use unsecured Internet Explorer. Giants. There's an article in the forum about it.
any other ones come to mind? Cool. Just a little plug too. Minted paid for all of our pizza and the event space and all that stuff. We do work in the building. Upstairs, we're hiring. Feel free to talk to me if you're interested. I lead the wedding websites team here. I'm a software engineer manager for that team. So,
If you haven't taken a look at their website, it's very standards compliant and very nice.
You can hack it.
It's
yeah. Check out our new. If anybody's getting married, our wedding website application will probably be a breath of fresh air. So, cool. Thanks, guys.